Hello students, today we're doing lesson 5.5 on prime factorization. So what we want to do is we're going to find the factors that when multiplied make a certain number. So let's just jump right in and do an example. I like this lesson because I get to teach you how to do factor trees. Later on in algebra you'll learn how to do factor ladders, but I'm only going to teach you the factor trees this time. Okay, so let's start with the number 30, and I'm actually going to show you how to do this a couple of ways, because you and the person sitting next to you in class could have totally different factor trees, but you will end up with the same answer. Okay, so I'm going to make two little branches coming off of that 30, and I'm going to say what times what, I need two numbers, equals 30. So you might have said to yourself 5 times 6 equals 30. Okay, and that's right. You have to pick two numbers that make 30. If you don't, you're going to get this wrong. And in my class, you can use your multiplication charts for this. Okay, you're going to circle any number that is prime. So remember, we just talked about prime numbers and composite numbers earlier in the chapter. And so you should know the prime numbers. And the most important ones are, or the ones you'll see most often, are 2 and 3. But think about the prime numbers from 1 through 20, and those are on your notes. Those are really important ones because those are the ones you'll see the most in the factor trees. So 5 is a prime number. So when you have a prime number, I want you to circle it. Okay? 6 is not prime because I can make two more branches. And I can make this 2 times 3 equals 6. And 2 is prime, so I'm going to circle it. And 3 is prime, so I'm going to circle that one also. And now when everything is circled and I don't have anything to make branches off of, you can't make a branch off of a circle, okay? You're not allowed to use ones in this. So we're not going to go like this and say 1 times 3, okay? No ones. So once I have them circled, I'm not going to have anything else to do. Then now I have my prime factorization. These three numbers equal, when I multiply these three numbers together, they will equal 30. So I'm going to go up here and I'm going to write those three numbers in order. 2 times 3 times 5. Let's test it. 2 times 3 is 6. And 6 times 5 is 30. So that works. So that means I have the right prime factorization. Okay. Now we're going to come back to this and we're going to do some work. We're going to do some work right here. But before we do that, I'm going to go down here and show you another one. So let's do a different number. Let's do I'm trying to think of a number. Let me look in your book and see if they have a good number to do. Okay, let's do 42 because that's example 1. Okay, my recording keeps messing up. So we are going to try this again. It probably doesn't look like it's messing up to you, but you might see some glitches in it. Okay, example 1, I'm sorry. That first one's, we're not calling it example because it's kind of me showing you how to do it. Okay, example 1, we're going to do 42. So I need two numbers that when multiplied make 42. You might say 7 and 6, right? Okay, so if I say 7 and 6, I look at those before I make any new branches and I say, okay, 7 is a prime number, so I'm going to circle it. 6 is not prime, it's 2 and 3, but so I make branches off of it and make 2 and 3, and then I circle those to be my prime factors. So now I'm going to put them in order from least to greatest. So I have 2 times 3 times 7. So up here, I'm going to put equals 2 times 3 times 7. Okay, so you could have this factor tree, and your neighbor could have a different factor tree. So let me show you that on like the first one up here, 30. Now, over here I did 30 was 5 times 6. But I'm going to do this one as 10 times 3. 10 times 3 equals 30, right? So when I do 10 times 3, so let's say, one boy, Johnny over here, did it this way, and now Susie's going to do it this way, and let's see if they get the same answer. So 3 is prime, so you're going to circle that 3. It's kind of a big circle. 10 is not prime, so I'm going to make more branches. So when I make the more branches, I'm going to do 2 times 5, because that equals 10. And then I'm going to circle those, because both of those are prime. So now look at what I got here. I have 2, 5, and 3. Well, that's the same thing as over here, only they're just not in the same order. But when I put them up here, I'm going to put them in order from least to greatest. So I have 2 times 3 times 5. So that and this one are the same numbers, so it does not matter what order you do them in. Okay, now after we learned, we did 47, I want to do one that's going to end up with a bunch of factors. So let's do 126. Okay, this is example 2, 126. So you might look at 126 and say, oh no, I don't know what to divide it by, or not what to divide by, but what two numbers make 126. But I do see that it's an even number. It ends with 6. So an even number is going to can be divided by 2. Well, if I want to find the other factor, then I would divide by 2 just off to the side. Just make yourself a little scratch paper. And that's 63. So on this side, I'm going to have 2. And on this side, I'm going to have 63. 2 times 63 is going to equal that 126. Okay, so 2 is prime, so I'm going to circle it. And 63 can keep being multiplied. So 63 would be 9 times 7. If you don't know what it is, find it on your multiplication chart and look up and then look to the left. And you'll see the two numbers. Okay, 7 is prime, so I'm going to circle it. 9 is not, so I need 2 more numbers. So the 2 more numbers for 9 are 3 and 3. Those are both prime, so I'm going to circle them. Now, on your work, we're going to write these down. Just a minute. I've got to erase all this mess because it's in my way. And now up here, I'm going to put them in order. So I have 2 times 3 times another 3 times 7. See how I put them in order from least to greatest? Well, now I'm not finished. I want this in prime, this is prime factorization, but I want it in exponential notation. So I want to put this with anything that's repeated as an exponent. So these two numbers are repeated. So I'm going to rewrite this as 2 times 3 squared times 7. And this is the way that you write it out if something has a repeated fraction like that 3 did. So we just rewrote 3 squared because up here it said 3 times 3. Okay, and this one is like you're going to be doing all your problems today. If it's a repeated fraction, you're going to do squared. In your book, it has, some of them tell you. Okay, in your book, it says use repeated division. We're not going to do that. Everything's going to be done with factor trees in this problem, in this lesson. So make sure that you use repeated, not repeated division, use factor trees, and make sure that you use exponents when you do it. Okay? And then they also have in there here, if you have, they don't have an example for this, but let's say this is your prime factorization. It will say, what is the number for this? And on some of them, they're doing it like this. They're saying, so what's that number? So all they want you to do is actually do the multiplication. So I would do 2 times 2 times 2, and then times 3 times 3. So all you have to do is do this in your head. 4, that's 4, right? Times 2 times this is 9. Now I have 4 times 2 times 9. That's 8 times 9. So that's 72. So x is 72. So you might have a couple of these also. And I think that's it. Okay, so that is how you do prime factorization using factor trees.